Hi, this video is on Earth geometry. We're looking at travelling along meridians of longitude. We're going to be using some questions from John Short's General 3 compendium to do this. Learning intentions. We are learning to identify whether two places are on the same longitude, draw diagrams to help calculate the angle between those two places, use the arc length formula to find the distance travelled either due north or due south on the globe, and we'll be using the arc length formula to work backwards and find a latitude given a distance travelled. So first thing, a quick reminder about latitude and longitude. First we'll look at the parallels of latitude. So these are those flat slices right through the Earth that tell you how far north or south you are. They're a measure of north or south from the centre of the Earth. So anywhere on this circle here, you're at the same degree north measured from the equator. So if we draw a line out from the centre of the Earth to the equator and then another one up to here, we'll have an angle here, and that'll be the same wherever you are on that circle there. Similar one down here, and the equator is the largest parallel of latitude, and it slices right through the middle of the Earth like that. Meridians of longitude, these are these big circles here, and they are all the same size. They all go through north and south, so it doesn't matter where you cut the Earth, you're cutting it exactly in half, and means you're always going to get a great circle. Now, if we were at this place here on that parallel of latitude, and we travelled down to this place here on that parallel of latitude, and we went due south, we would be travelling along that meridian of longitude. Now, if we just put a point there in the centre of the Earth, what that means is, if we just draw those lines out from there to there, that we have an arc which we can calculate the length of. All we need to know is what the angle is here, because we know what the radius of the Earth is, and that's approximately 6,371 kilometres. So we have enough information to be able to work it out if we know how far north this place is and if we know how far south this place is, which means we need to know what that latitude is there and what that latitude is there, and providing the longitudes are the same, which means they're the same distance east or west, it means we'll travel straight down or straight up along that meridian of longitude. Okay, so this diagram here is similar to one we were just looking at there. We've got a point up here and a point down here, and we're told now that this is 40 degrees north, the first one, and this is 22 degrees south. And we want to know, okay, if these are on the same meridian of longitude, how far apart are A and B if you travel due north or due south? And we can work that out. One of the easiest ways to do this, though, and it's a good habit to get into now, is to imagine that, remember, if we cut through north and south, we get exactly halfway through the Earth. So if we were to cut through the Earth, we'd actually see that from the side. We'd see a cross section. Now, north's at the top, south's at the bottom, the equator is in the middle, and A, we're told, is 40 degrees north. So that means that this angle here is 40. And we're also told that B is 22 degrees south, which means that this angle here is 22. So in total, we have an angle here of 62 degrees. Okay, now before we calculate that, we need to remind ourselves of the arc length formula. So the distance here of this arc there, D, is equal to 2 pi r, which is the circumference of the circle, but we don't want the whole circumference, we just want a proportion of it, which is theta out of 360. And r is the radius of the Earth, which is 6,371 kilometres approximately. So we can now do this. We can calculate the problem we had before. Now you can see here the original question here: calculate the difference travelling southwards from A, 40 north, 25 east, to B, 22 south, 25 east. So this is a diagram that we were looking at before that represents this problem: 40 north, 22 south, 40 north, 22 south, and they both happen to be, now this is important, they both happen to be 25 degrees east. That means that they are the same measure east or west, which means that they're on the same meridian of longitude. So we can travel due north or due south between them. Okay, so we've got our diagram here, and we already worked out that that was 40 degrees, that was 22. It meant that theta was 62 degrees, and so D is 2 pi r times theta over 360. If we then sub in that information, D is equal to 2 pi times 6371 times 62 out of 360. You can use your calculator to work that out. So it's 2, use your keyboard, you can find pi, so 2 pi times 6371, and that's times 62 out of 360. And that gives us 6894.0854. So 6,894 kilometers, 0.09 to 2 decimal places. Okay, so that would be our final answer, and that's what you should write down here, is that D is equal to 6894.09 kilometers. All right. Now, here's an example from, or a couple of examples from set 3 in John Short's textbook. So we're just going to look at a couple of those. This one, question 14. Now, that's how you're given the question originally. A and B, and they're 44 degrees apart in total. A good idea, again, as I said, to draw yourself a cross-section like that. So you draw your cross-section, and then you put 40, actually, we don't know what the separate ones are, but in total it is 44 degrees. That way you can use D equals 2 pi r times theta over 360. D is 2 pi times 6371 times 44 out of 360. And again, put that in your calculator. And we're going to have 2 pi times 6371 times, this time it is 44 out of 360. So our answer is this time 4,892.58 kilometers. Incidentally, it might just be worth pointing out now that the total circumference of the Earth would be 2 times pi times 6371, and that would be it, 2 pi r, which is 40,030 kilometers. So that's all the way around the Earth in kilometers. So if you get an answer that is way above that, you know you've done something wrong with your working out. That's the absolute maximum, and that would be all the way around the Earth. So halfway around the Earth would be about 20,015. Okay, this is 14b, and as you can see, this time we're given two measures. So we've got 38 degrees north there and 27 degrees south. If we draw our cross section, then what we're going to get is 38 there and 27 there, giving us a total of 65 degrees. So theta would be 65. Put a slightly nicer diagram up there. You see the same thing, so we'd have 38 there and 27 there, so a total of 65. So again, that means we can use D is equal to 2 pi times 2 pi r times theta over 360, giving us 2 pi times 6371 times 65 out of 360. And again, you can use your calculator to work that out, and we will get a 7,227.67 kilometers. So that would be our final answer. Now, 14c is interesting here. You can see they're both in the northern hemisphere this time. So we've got a place that's 59 degrees north and 20 degrees north as well. So in this case, it makes it even more important that we have that diagram really clearly drawn out. So I'll use this nice version I've got here. So the place A at the top is 59 degrees north. So I'll just use some different colours to highlight this. That means that angle there is 59 degrees. And B is 20. So let's see if I make that one purple there. But what I want, sorry, that was 20. What I want is to know A to B. So if I use another colour there, you can see that the green line would be the blue angle, subtract the purple one. So for the green one in the middle, I'm going to have 59 minus 20, so it's going to be 39 degrees. So in this case, theta equals 39 degrees. D will then equal the same as before, 2 pi r times theta over 360. Sub in your values, we're going to have 2 pi times 6371 times, what did we say it was, 39 out of 360. If you check that on your calculator, you should get 4,336.60 kilometres to 2 decimal places. So that would be our final answer, 4336. I think I can copy over, there we go. So D is 4336.60 kilometres, and that would be our final answer. Don't forget to put in your units. Okay, this question 16. Barbados and Buenos Aires are both situated on the 60th meridian of longitude, so 60 degrees west. Barbados at 14 degrees north and Buenos Aires at 34 degrees south. Find the distance between them. Because they're on the same meridian of longitude, it's just like our questions before. Draw a slice through the Earth, and this time we have 14 degrees north there. That means A is Barbados. We don't have to label it A. And Buenos Aires is 34 degrees south, so that would be Buenos Aires, and that's 34 degrees south. So you have a total there of 14 plus 34. It's going to give us 48 degrees for theta. Work it out then in exactly the same way. D is 2 pi r times theta over 360, which is 2 pi times 6371 times 48 over 360. Use your calculator then to work it out. So it's going to be 2 pi times 6371 times, what do we say, 48 over 360. So 5,337.35. 5,337.36 rather kilometres. Make sure you write your final answer, and again, always include units, so it's in kilometres. Okay. Last question's a bit different. Question 19. This time we are told that it's flying due north, so we know it's travelling along a meridian of longitude. We're also told it travels 2,500 kilometres, and we're also given its starting point here. So we know it starts at 60 south and then goes somewhere north, and for a distance of 2,500. Here's the diagram we can draw. So we start at 60 degrees south, it's down here. We travel for 2,500 kilometres north. We don't know what that angle is, but we can work it out, and then we can use that to find out where it is exactly that we finish. So using the same formula, D equals 2 pi r times theta over 360. This time sub in slightly different information. 2,500 we know equals 2 pi 6371 times, and we don't know what the angle is, so we don't know what theta is. Now you can use your calculator to work this out. If you haven't done this before, go to interactive, advanced, solve, and we're going to type in 2,500 equals 2 times pi times 6371 times theta, which we don't know. We're going to call x over 360 and solve for x. So we get 22.48. As you can see, I just checked that earlier. So 22.48 degrees is that angle. So theta 22.48. That angle there, theta there, is 22.48. So if we were 60 degrees south and we've gone 22.48 north, then we're going to be 60 minus 22.48, which is 38.52 degrees south. So we now know our final finishing point, where we finished, because this is 38.52 degrees south, and we haven't moved off here. So our final place is 38.52 degrees south, 120 degrees east, and that's where we finish. Right. Just as a quick recap then, if you travel due north or due south, you are travelling on a great circle, one of those slices straight through the North and South Pole. If you see two places, for example, A 23 degrees north, 10 degrees east, B 11 degrees north, 10 degrees east, you can see straight away that you've got the same longitude here. So they're the same measure east or west, which means you can travel due north or due south between them. Always draw a diagram. So a cross-section for these types of questions, a cross-section through the Earth. Use the formula D equals 2 pi r times theta over 360. Remember, r is 6,371 kilometres approximately to find the distance travelled in kilometres. Okay, that's it.